Okay, so this is the question. A charged particle of mass m, charge q, enters with a horizontal velocity u into a region of width d having a uniform electric field. Find the velocity v and distance covered by the particle after it leaves the field. Ignore gravity. Now, this is the region of width d, and this is the direction of electric field. Now, the confusion is that can we consider this as width d? No, here's the problem. If you consider this as width d, that means the electric field is only in this region and no field after this region, and that would mean that the field is non-uniform. So for the field to be uniform throughout the region, the width d must be considered perpendicular to the field, and the velocity u must also be considered. Let me choose a different color. The velocity u must be considered parallel to x-axis. So, as we can see, there are basically there are two motions. It's not going. Okay, no problem. We can see there are two motions. One is along x-axis and the other one is along y-axis. So first we must understand, for the motion along x-axis there is no force, no acceleration, and the particle is going to move with a constant speed u. So we can very simply say d equals to ut. Along y-axis the force is qe, the acceleration along y-axis is qe by m, and we can say that the distance covered by the particle y is equals to half qe by m into t squared. Now we can substitute t from this equation here and find out the value of y, and then we can get the answers. So y will be basically equals to half qe by qe by m into d squared by u squared, and that is the value of y. And when we have found out the value of y, the path of the particle is going to be something like this. So this is obviously y, this is y, and we can also find out the velocities vx and vy. Vx would always remain u, not changing. Vy would remain acceleration into time, that is qe by m into t. Again, the value of t can be taken from here, that is d by u. Now, how do we find out the distance covered by the particle? How do we do that? The distance covered by the particle is simply the length of the path. Here, this path here. So if you want to find out the length of the path, let me take up another diagram here. If you want to find out the length of the path, you have to consider both the speeds, vx that is equals to u, vy that will be equals to qe by m into t, and the total speed can be given as root under Vx squared plus Vy squared, that will be equals to root under u squared plus QE by m into t squared. When you have found out the speed, the length of the path is easy to find. The length of the path is simply v dt, and we know what the time is. It starts from 0 and ends up to d by u. So we'll have to integrate this. Now that is something that I can give you in another video. T squared into dt integrate.